Next up, I'd like to introduce Wim Van Deun, who will be presenting Now You Can Too, Design-Driven Automation. Wim is a solutions architect at OpsMail and traveled from Belgium to join us today. This is Wim's first time speaking at NANOG, and it's a pleasure to have him speaking with us today. Welcome, Wim.
All right. Can everyone hear me well? Great. So thank you everyone for taking the time to attend my talk on Now You Can Too, Design-Driven Network Automation. A little bit about me. My name is Wim Van Deun. I'm a solutions architect at OpsMail. Throughout my career, I've been always focusing on network automation, really. Even back in the days when Perl and Expect were still the de facto standard tools, I was already trying to solve some of the challenges that we still see today. And then when network automation really became a thing, I was able to make that passion of me really, I turn it into my job and make a little bit of money out of it. So OpsMail is the new kid on the block, or one of them. We have been founded in February 2023. And actually last Sunday, we celebrated our 2 years anniversary. So congratulations, OpsMail. Our motto is simplifying complexity, enabling agility. And what that means to us is that we are focusing on building tools and software for infrastructure automation. So we are now around 20 employees that are spread over the US and the EU. And we are a 100% remote company. We fundamentally believe in the open core model, similar to how the company behind GitLab does it, which means we produce open source software and we build enterprise features on top of that. So today I want to talk mainly about design-driven network automation. But before I can, and some of the challenges that we see with the current tooling that already exist in the space. But before we are going to dive into that, I want to introduce Infrahub. And mainly that is because there is some features in that project that we are going to be able to showcase to show you how we can solve some of the challenges that we see. So what is Infrahub? It's a next generation source of truth. But as we already heard this morning during the panel, that term is a little bit, it's generating discussion, let's say. So you could also think of it as an infrastructure automation data management platform. It's an open source project released under the AGPL v3 license. Some of the features that make us stand out compared to other sources of truth is that we have an extensible data model, which is built on top of a graph database. We have version control, a native CI, and we have some smart integrations. So design-driven network automation. Design-driven network automation is an approach to data management for infrastructure automation. It's not really something new that we're going to be talking about. In fact, there has been previous presentations at NANOG. For example, Jeremy Shulman did a presentation during NANOG 88, where he has been talking about design-driven network assurance. There's implementations of design-driven network automation. For example, Arista AVD, which is a design-driven network automation approach implemented on top of Ansible. You have Network to Code's design builder application for Autobot. And also Google has been talking about their MALT implementation, which is a multi-abstraction layer topology at NANOG 80. And it's not necessarily design-driven network automation that they were talking about, but I think a lot of the ideas that they have brought up during that talk have definitely influenced what design-driven network automation really is. So if we step back and look at this enterprise organization, a typical enterprise organization that starts with network automation, something that all of those organizations try to solve is, for example, when they need to build a new site, they're going to build a script that helps them automate device configuration generation, right? So that script would be, either an Ansible playbook or it could be a Python script. And in that script, they need to feed in some input, the site that you want to generate those device configurations for, maybe a loopback prefix out of which you want to assign IP addresses, a vendor, some type of a design, large, medium, small, and a number of racks. And then you would generate those device configurations and everyone would be very happy. And I mean, it's a fantastic achievement. But then later on, you start to realize that you have no clue anymore. You have the device configuration, but you have no clue anymore what was the design that we used to generate that configuration. What was the input that we used to generate that configuration? All of that information is completely getting lost. Or even to build those device configurations in the script, you have been generating data, but you have not stored that data, which is extremely useful when you want to start expanding on this type of approach. So that's what we see. That's how we saw the industry move towards a more framework approach, where design-driven automation really came in. So this big monolith script that generated device configuration is now abstracted into multiple pieces. So first of all, we are going to think about a design and make a design really a data structure that we can programmatically reason about. It's not anymore like this thing where it's a visual drawing, but it's really a data structure about which we can programmatically reason. And then you have your input. Those two would then be taken by a script or a job, a build side job, which could still be Python or an Ansible playbook that would take that design and the input and then generate a design implementation of that into your source of truth. It would still take a similar input as it was previously, but it's now really a data structure. Then we have also abstracted the configuration generation itself into its own building block that now consumes the data out of the source of truth and then generates configurations from that data, from the implementation of your design. Now, it doesn't stop with device configurations because now you can reuse that same information in the source of truth or your design implementation to generate lower level design documents, like a cabling plan or some type of a report. But we could also use it to generate testing data or anything else. Or maybe even a monitoring system could use the same design implementation to understand how it should be monitoring your infrastructure. But there is still some challenges with this approach. So first of all, we have now abstracted the design into a data structure and the input into a data structure, but we are not storing that design and the input together with the implementation, design implementation into the source of truth. And we do that because, or we don't do that because it's a complex data management problem that you have. Storing that data is not easy. But because of this, a lot of the context get lost. So if you look at the design implementation in your source of truth, while you don't have that input object in the design that was used to generate it, you lose the understanding of why a certain device was even created or why it is configured the way that it actually is configured. So, and that really leads to a situation where we are fairly good now at automating the day one operation, where we populate the source of truth and we can generate configurations out of that. But day two operations become harder. Think of evolving a design standard. Like if you don't have the relation between your design implementation and your original design, then it's going to be very hard to reason how you need to evolve that design to a new standard. And on top of that, there's a lot of organizations today that are looking to offer a service catalog where they can offer these type of infrastructure services to other teams in a self-driven way so that they don't need to be involved too much with that. The problem is if you cannot store those inputs and those designs in your source of truth, you're never going to be able to reach that. So one of the realizations we had is that it's all about the data, right? If you think about it, the design and the input data that we give to that design are really business data. It's data that is particular to your organization towards your workflow. There's no two companies where that is exactly the same. So it's a little bit custom, and you are going to have to be able to define your own data model if you want to be able to store that in the source of truth. On top of that, we need to store the technical data. And technical data is the devices or the IP addresses and the interface. And I think in the industry, we all have a fairly common agreement what those things should look like from a data perspective. Now, the challenge is that we need to be able to store those two together in the source of truth, which is not easy today. And we need to do that because we want to be able to capture that context around design implementation and which design was used to create that design. So we really need to have some form of a capability that allows us to be very flexible in the data models. If you want to do that today, there's already different options. So first of all, there's the JSON YAML file approach in a Git repository or infrastructure as code, which is great because in JSON or YAML, or in fact in a Git repository, there is not really a schema or a specific data structure that you have to follow. So you have ultimate flexibility. But a Git repository is not a database. So if you want to query for that data within the Git repository, it's going to be hard because you have no query engine that you can use to retrieve the data out of it. On top of that, JSON and YAML files are hard to consume. I think for technical people, it is mainly going to be okay, but if you're less technical, then it might not make sense what is within those files. Another option that we see is when you use a database in a bespoke tool that has its own data models, and you can extend those data models, for example, with a JSON attribute. So again, you have quite a little bit of flexibility because JSON is not really strict on the schema of the data that you put into it. But in such a bespoke tool, you might lose the ability to have version control like we have in a Git repository. On top of that, we have not solved really the querying problem because you can retrieve the JSON attributes out of the database easy, but the data within the JSON blob are still hard to query. And arguably, again, JSON hard to consume for less technical people. A third option would be that you completely develop a solution on your own, which gives you ultimate flexibility because you are in control of the data schema, you're in control of the schema. You can build your own API that leverages a query engine to the database, etc., etc. The challenge there is that you are going to have a very specific skill set within your organization. And if you have the availability of that skill set, it's still going to take you a lot of time to implement all of that, and arguably is going to cost you a lot of money. So that's why Infrahub has a flexible schema. That basically means that you can build any kind of data model in the tool. And it's fairly easy to do that. So we basically allow you to describe data models using a DSL in a YAML file. And it's relatively easy. You don't really need to be a database expert to be able to develop such a model. So on the right side, you can see an example data model where we describe that same site as we did in the previous slides. So the site has a few attributes like a name, a prefix, and a rack count, and it could have a relationship to another data model, in this case, for example, a vendor. On top of that, we made, or Infrahub makes it easy to consume that schema or the data within the data compliant with that schema. When you load your schema into Infrahub, it is going to automatically generate a GraphQL, all of the GraphQL queries for you in GraphQL mutations that allow you to retrieve, create, or update data. And on top of that, it is going to generate all of the UI views and forms that you need to be able to manage that data in it. So it's arguably much easier to consume than pure JSON or YAML files. So I want to show you a little bit what that looks like in Infrahub. So we start with an empty instance. So you can see on the left side of the menu, for example, that there is basically almost no menu entries. There's just a few of them that are there out of the box, but there's no data models there. So the first thing we are going to do is load a schema, sorry. No. I think it starts now. Yes, sorry for that. So the first thing we are going to do is load the schema into Infrahub. We do that using a command called infrahubctl schema load. And it's going to load these YAML files in which we declared our models. It takes a bit of time. So just a reminder, in the backend, it is generating all of these GraphQL APIs for us. And it's also generating all of the UI views and forms that will allow you to manage all of that data. So it is now finished. And if we refresh this page, we will see that in the menu on the left, we now suddenly see all of these models pop up that we have defined in our schema. So we will have a quick look at this topology object, which is almost the same as the site object that I showed you before. So you can see that we had a list view of all of the topology objects, and we have a detailed view that allows you to see more detail about that data object that you have defined. And this is the form that allows you to modify all of that data. So all of that was generated because of the schema you loaded. Then last but not least, we have the GraphQL API. So here we have a query that we can use to retrieve that specific topology object. I'm not going to go in too much detail about GraphQL. We actually have a lightning talk later today that you can attend if you want to learn more about GraphQL APIs. So now we have the challenge solved where we need to be able to store business data together with technical data within the source of truth. But we still have a problem, and we need to talk about the design builder next. And the design builder is going to be a logic or a script business logic, basically, that takes your design and input that you have stored in the source of truth and generate a design implementation for it. Now, the challenge is that we were able to create that data now in the source of truth, but we haven't really talked about how we can create a relationship between the design implementation and the design and the input. Well, that's what the site builder job is going to be responsible for. So we need to be able to store that builder script or that business logic that you use to create your design implementation into the source of truth as well, to be able to link the input together with the output. On top of that, we really need this to be a repeatable process. We are going to use that later on when we talk about day 2 operations, because the repeatable process allows us to be able to detect drift from a previous design implementation, for example. But to make the design builder repeatable, we really need to have a behavior which is called idempotency. So what is idempotency? It's an operation that, given the same input, is always going to be producing the same output if you run it multiple times. So we're going to be able to use that behavior to be able to detect drift from original design implementations. Just to put that into perspective, or to give you an example of that, we are going to talk a little bit about a workflow that a design builder could do, which is assigning IP addresses to interfaces. So the first time that the design builder runs, this is a fairly simple operation because you have your interfaces and you just need to assign an IP address to each individual interface. But the second time that you run that same design builder and maybe you have added a 4th interface, what you really wanted to do is only add an IP address to that 4th interface. And it should not assign a new IP address to those 3 previous already existing interfaces. So that's really what idempotent behavior is. We are not going to be assigning IP addresses to the interfaces that we already assigned IP addresses to. But to be able to do that in a design builder, you are going to have to be able to interpret the state of the database, right? You need to understand what has already happened and what do I still need to do. If you will need to implement that in your design builder, that's going to be a fairly complex challenge. On top of that, these design builders will need to be declarative. Declarative behavior is the exact opposite of imperative behavior. We're going to use an example again to explain what we really mean with that. So on the left side, we have, again, this fictive design builder, which takes an input and is going to use some business logic to create a design implementation. In this case, we created 5 devices, a number of interfaces, etc., etc. Now, we want to use a new version of our design builder to implement a new design. And we use that same input, and now the output of that design builder has to change. The design implementation has to change. Instead of 5 devices, we now have 4 devices. And instead of 200 interfaces, we only need 150 now. In an imperative approach, your design builder would now have to consider the state of the database, and it would need to retrieve it and then interpret what it exactly needs to do. Like, we need to tell it to remove exactly 1 device and then remove 50 interfaces. Whereas in a declarative approach, that would be completely different. We would not consider the state at all, and we would just describe what the end state should be, aka we need 4 devices, 150 interfaces, and we leave it up to the system to resolve that delta between the previous state and the new state. So that's, in Infrahub, we have implemented generators as our design builders. So out of the box, they are idempotent and declarative, and it's a repeatable process, meaning that we can use them to generate drift from design implementations later on. On the right side of the slide, you can see an example where we leverage the Infrahub SDK to create a simple site builder generator. This site builder generator is just simply going to create a number of devices, which is defined in the input, which is this data object that you see. So notice that we don't really care here what the state of the database is. We just declare that we want to create X amount of devices, and we leave it up to Infrahub to solve that for us. Another important tool that Infrahub provides to be able to resolve this idempotent behavior challenge is the resource manager. So it goes back to the previous example where we were assigning IP addresses to interfaces. So now we're going to introduce this resource manager in between. And the role of the resource manager is to manage resource allocations. Think of IP addresses, prefixes, or numbers, but it could be other types of objects as well. So the role of the resource manager is to track the ownership of an allocation. So basically, it's going to keep track of the resource that it has allocated and to which resource it has allocated it to. This is fairly similar to how, for example, a DHCP server would work. So in a for DHCP, you would have a host that requests an IP address, and then the DHCP server is going to keep track of which IP address have I assigned to which host. And it does that by keeping a relationship to an identifier. For DHCP, that's going to be a MAC address. But here, the resource manager really keeps that same kind of relation, but we use the ID of the object in the database. So now that we have that capability, we can idempotently assign IP addresses to, or resources to some objects in the database. And we simplify what you have to do in your design builder because you can delegate the resource allocation to the resource manager. You don't have to worry about the state at all. On top of that, resource manager resolves as well the challenge that you might have when you have multiple design builders running concurrently. You could have multiple scripts that run concurrently and that want to assign an IP address out of the same pool. So at all times, you want to avoid that it would assign the same IP address to different resources. So that's what resource manager is for. So in this next demo, we will be showing what a generator looks like. So the generator has started to run. So uses that topology object that we were talking about before. It's now producing logs, and it's going to create our design implementation. As we can see, it has now added the devices that we had described in that topology object. It has created multiple IP addresses that were allocated using the resource manager. And we have some BGP sessions that also have been added here. Now, if we have a look quickly at the resource manager, or one of the resource managers that we have used, we can see that it manages a specific prefix, out of which it makes IP address allocations. And we can see here some of the IP addresses that it has allocated and how it tracks that. So it keeps a relation to the IP address by using its ID in the database. So now we have solved the challenge where we wanted to store the business data together with the technical data, and we had to implement design builders that work in an idempotent and declarative way. It's a repeatable process. Now the next part is, how can we use that data that we have generated to do useful stuff with it? And therefore, we need to talk about data transformations. So this is really the idea of, we want to consume that design implementation data in the source of truth to be able to generate other types of data from it. Could be a device configuration, could be test plan data, or it could be other types of lower level design documents. The problem is that with this standard or the previous approach is that if you have a device configuration, you still are not able to know what the state of the database was when you got this artifact. You have no idea of that. You have the artifact, but you don't understand the data that it was used to generate from is completely disconnected from the artifact itself. That creates a challenge. Like, first of all, we could have a challenge because we don't know the state of the data, so it could mean that the generation process for that configuration is not in line anymore with the state of the data. So it means that problems are going to be surfacing too late in the process, maybe at deployment time, and you want to absolutely avoid that. On top of that, because we don't have a relation between what we generate from the data and the data itself, and we are going to create a big scaling problem. Because at this stage, whenever there is a data change in the source of truth, we have no idea which exact artifacts we have to regenerate. So basically, the approach we take today is that on a certain schedule, we are going to just have to regenerate all of these artifacts all over again whenever the database has changes. Now, that's not a problem when we talk about 100 devices that you manage, but if it's 1,000 or 10,000 devices, that is really going to become a scaling problem. Infrahub has artifacts to resolve that. So Infrahub stores artifacts together with the data in the source of truth, as well as the transformation that was used to generate that artifact. So that allows us to link the design implementation together with the artifacts that were generated from it. And that allows us to also solve the scaling problem that we talked about previously. Because we have stored the artifact in the source of truth, we can introspect it and understand exactly which data objects in the database affect this artifact. So because we can do that, we understand exactly which artifact needs to be regenerated when there's data changes within the database. So that means when there is a database change, we know exactly which artifacts we should regenerate and which we can just leave alone. On top of that, because we store the artifacts within the source of truth, your deployment process becomes much easier. Previously, we were always generating the configurations, typically using the deployment system like Ansible. But now we don't have to do that anymore. We can just fetch the latest artifact from the source of truth and then deploy that onto your infrastructure. Which also is another benefit of storing them together, is that when we retrieve an artifact from the source of truth, we know absolutely sure that it is in sync with the data, the state of the data in the database at that point in time. So what do artifacts look like in Infrahub? So we'll quickly have a look at an artifact definition. And I probably forgot to mention it before, but you can use Jinja templates to do data transformations. In this example, we are referencing a Jinja template that we use to generate device configurations for Arista devices from the data within the source of truth. We click the Generate button. So now if we go to an Arista device on the Artifacts tab, we will be able to see that generated artifact for this device. So we see, a bunch of configuration, interfaces, a VXLAN VTEP interface. There's going to be some BGP configuration there. And then we can also access that same artifact or device configuration using the REST API. So if we click on that link, then we use the REST API endpoint to get that data out of the system. So this is what your deployment system could use. So I mentioned that you can use Jinja 2 for transformations, but you can also use Python transformations. So basically a Python script that would get the implementation of the data out of the database, and then you can use Python code to generate whatever type of artifact that you want, maybe another type of data structure or a JSON file or whatever. So now we have solved the problem of the data management by storing the business data together with the technical data. We have solved the design builder challenge, so that it needed to be an idempotent design builder. It needed to be declarative. We need to make that a repeatable process so we can use it for drift and to be able to do day 2 operations. And we can generate configurations or other types of artifacts out of that data, and they are all linked together so that we can programmatically reason about if a design needs to evolve, what exactly needs to happen, and what are the following actions that need to happen out of that. So in this demo, I want to show you what that really looks like from an Infrahub perspective. So we're going to take that topology object again, and in a declarative way, we are going to expand the capacity for that topology. We're just going to add 2 new leaf switches. We're not going to tell it how to do that, but we're just going to add the number. So that's what we mean with modifying the input. Then we will see how the design builder or the generator updates our design implementation, and then how we use artifacts to regenerate existing configurations for affected devices and new configurations for the new devices that we have added. So first, we will be modifying the topology object. Instead of 6 leaf switches, we're just going to state that we now need 8 of them. So declaratively describing how we want the topology to change. In the backend, the generator has run and interpreted that input that we gave it, and it has now added those 2 new leaf switches. On top of that, it has also modified the spine switches, so we can see that the interfaces have changed, and they are now hosting the connection to the leaf switches that we just added. There's a new autonomous system that has been added for which the leaf switches will use. And the relevant artifacts have been updated. So we can see here the spine switches, their interface configuration has been updated, an IP address has been added, etc. And we can see the startup configuration now for those new leaf switches. So now Using this design-driven network automation approach, we were able to modify a design implementation relatively easy. So last but not least, we need to talk about version control and CI, or continuous integration. This is not strictly required to implement a design-driven network automation approach, yet I do think there is very useful things in version control that we can use and apply to design-driven network automation. So version control is really something that comes out of the infrastructure as code space. The goal of version control in infrastructure is mainly to track how your infrastructure changes. But on top of that, it's also really a collaboration tool where you can create isolated environments in which you can modify infrastructure changes without, collapsing into each other's work. You can prepare changes in your own isolated environment while your team member is, preparing his change in another isolated environment. Another very important aspect that we want to use from version control is peer review, where you can propose a change and someone else is going to have to review that change and approve it or decline it or suggest some improvements that need to be made. But also, in a peer review process, we can do automated checks to validate maybe your data that you have modified. So in Infrahub, Infrahub implements version control on top of the database. So what that really means is is that it implements Git-like concepts on top of its database. So you can create branches or isolated environments at the database level. To be able to do that, we really need to have immutable data in the database, which gives us another advantage because it means that we can track how the database has changed over time or how objects have changed over time. So conceptually, what it looks like, if you look on the left, is that you have a main branch, and in that main branch, you can have a version of your implementation data, but also your design builder job or your transformation that was used to generate your configurations and the artifacts itself. In another branch, each individually of those components could change without really affecting the main branch, which allows us to make changes to the database without really affecting the production state of your database. On top of it, it also implements continuous integration, meaning that whenever you open what we call a proposed change, which is very similar to a pull request in Git, you will be able to provide your peer review feedback, but also that we do at that stage start a continuous integration pipeline in which we can run custom data validations. So you could write your own data validations in Python, import them into Infrahub, and have them check the data whenever you want to make a change to the data in a branch. But also it gives you the ability to provide unit tests, for example, for your transformations. So this allows us to solve that challenge that we just talked about before, where you might detect issues with generating configuration way too late in the process. We can actually detect those problems whenever the data changes in the database. And last but not least, we use it to assure data and schema integrity. So what does that look like when we bring it all together? And quickly, sorry for that. I'll start the demo again. So we're going to repeat one of the first demos where, or actually we're going to bring it all together now, where we are going to show you how you create this topology in a branch. So we have created a branch in the system, and we have our topology object that we created in this branch. So now, when we open a proposed change, which is, again, similar to what a pull request in Git would look like, we're giving it a title. The generator is going to run, the artifacts are going to be generated, the CI pipeline is going to start, as we will see that certain tasks pop up here. And then we can see the status of them where hopefully they shall all become green. So we are now running data integrity checks, but also we run user-defined checks. We are checking the artifacts in the generator. So now all is green. We have validated that all of the changes happened correctly, and that and we can see the data changes here. So now all of these changes happened in a branch, meaning that the devices that were created for this topology have been created in a branch. All of the other objects as well. We have generated the artifacts in a separate branch. So if we now switch to the device view, we can see effectively the objects exist within the database, within this branch, and we have the artifacts. But if we now switch to the main branch, which we are doing right now, so we switch to the main branch, you will see that none of these objects yet exist in the production or the main branch of your database. So we'll go back to our proposed change now. And we are good with this change. All of the checks were fine, so we click the merge button. The branch has now been merged into main. And if we check in the main branch now, we can see the devices that previously existed in that other branch. So similar to how infrastructure as code has done it. So that concludes the presentation. So in summary, what have we talked about is design-driven network automation and some of the challenges that we saw with it in current tooling. How we used a flexible data schema, idempotent and declarative design builders to solve some of those challenges, and how we leveraged version control and continuous integration to apply infrastructure as code principles to our database. So last but not least, we would love it if you give Infrahub a try. Again, it's an open source software. There's links to our website, to our GitHub repository, the documentation, and always on demo. Feel free to join our Discord, and thank you, everybody.
Wow, that was great. Thank you very much, Wim. Do we have any questions from the audience?
Zoe Feiner with Arista. So you were mentioning the concurrency problem when you're doing resource allocation through the manager. When you're using multiple branches, is the resource allocator sitting outside of your branch structure, or
Yes.
are you doing, okay.
Yes, so it's, we call it branch agnostic. So it keeps track of which allocations happened in a branch, and it's not going to be able to assign that same resource to another resource in a separate branch, basically.
Perfect, thank you.
Yeah.
Any remote questions? Yep.
Thomas Scott CoreWeave. Wim, thanks for the presentation. This is cool stuff. You mentioned that this is a blank slate, right? Like it's not like Netbox or Notabot where you kind of get the whole spreadsheet that already exists that we're all used to. What challenges have you guys found as you seek to onboard or to consult with designing, as far as like figuring out how to make a model that works for whoever you're working with?
Mm-hmm. So it's an excellent question. So I think it's definitely a strength of Infrahub that it has a flexible schema, but simultaneously it can be a challenge when you have to start, right? If you have to write your own schema, it can be very challenging in the beginning. So what we mainly do is we provide example models for some of the base technical stuff that you can leverage, and if you are comfortable with those models, you can just use them. If you feel the need to modify them, you can modify them in any way that you like. The business data is a little bit harder because we can give you examples, but you're going to have to really figure out within your business what is a design, what is a service, and what do we need to store about all of that data. We can guide you on that journey, let's say, but yeah, that's really custom, and that will need to be custom-made.
Very cool. Well, one follow-up. How big have you guys scaled this?
Scale this in what way?
Devices, services. So we're talking about a graph database. How many nodes have you guys gotten to in total?
I can take that question offline. There's a lot that comes into play. Like if I have 1,000 devices, but I only store one attribute for that device, it's totally different. And like it's hard to give you a concrete number at this stage. So I would probably need to get a little bit more information about what exactly you want to do. But yeah, I mean, it scales. We have customers at this stage generating huge AI cluster with this, so it scales.
Very cool. Thanks, Wim.
Exact numbers.
One more online question. How does Infrahub handle the situation where multiple automation clients are wanting to update the central SOT database simultaneously using API calls? And what if the updates are related?
It's a good question. So actually, when we talk about modifying that in the main branch, Infrahub is going to implement logs on the data so that you can never have two clients that simultaneously update data simultaneously. Yeah, that's how we would prevent that from happening.
Any final questions? Well, thank you again. This is amazing stuff.
Thank you.